Hey there, fellow gardeners and plant enthusiasts. Welcome back to Smart Garden, where we dig deep into the secrets that transform ordinary gardens into extraordinary growing spaces. I'm thrilled you're here because today we're about to uncover something that will completely revolutionize how you think about plant care and soil health. What if I told you that the biggest breakthrough for your garden isn't above ground, but buried beneath your feet? Forget what you think you know about soil amendments. This isn't about sprinkling a little yeast on your soil and calling it a day. We're talking about unlocking a microscopic superpower that can redefine what exponential growth truly means for your plants. Today we're diving into the fascinating world of soil microbiomes and discovering how these invisible allies can transform your garden from surviving to absolutely thriving. For decades, gardeners have approached plant care with a fundamental misunderstanding. We've been taught to see plants as individual organisms that simply need water, sunlight, and perhaps some fertilizer to flourish. This traditional thinking has led us to focus primarily on what we can see above ground, while completely missing the hidden world beneath our feet. The truth is, treating plants as solo performers is like trying to understand a symphony by listening to just one instrument. Every plant in your garden exists within an intricate, bustling underground metropolis teeming with life. This invisible network, known as the soil food web, is where the real magic happens. Beneath the surface, billions of microorganisms are working tirelessly in a complex dance of cooperation, competition, and communication. These microscopic communities include bacteria, fungi, protozoa, nematodes, and countless other organisms, all interconnected in ways that directly impact your plant's health, growth, and resilience. When we see stunted growth, yellowing leaves, or poor flowering, our instinct is often to reach for fertilizers or pesticides. However, these seemingly isolated plant issues are frequently symptoms of deeper soil imbalances. A plant struggling with nutrient deficiency might not need more fertilizer. It might need the right microbial partners to help it access and process the nutrients that are already present in the soil. Understanding this connection is the first step toward becoming a truly successful gardener. While adding yeast to soil can provide some benefits, focusing solely on one type of microorganism is like trying to create a gourmet meal with just one ingredient. A truly healthy soil microbiome is an incredibly diverse ecosystem where different types of microorganisms work together in sophisticated ways. The foundation of this underground ecosystem begins with bacteria, the most abundant microorganisms in soil. These microscopic workers perform countless essential functions, from breaking down organic matter to producing plant hormones. Nitrogen-fixing bacteria such as Rhizobium species form intimate partnerships with legumes, converting atmospheric nitrogen into ammonia that plants can readily absorb. Meanwhile, phosphate-solubilizing bacteria work like tiny chemists, secreting organic acids and enzymes that unlock phosphorus compounds, making this crucial nutrient available for plant uptake. Fungi represent another critical component of the soil microbiome, with mycorrhizal fungi forming some of the most important plant partnerships in nature. These remarkable organisms create vast underground networks of thread-like structures called hyphae that extend far beyond a plant's root zone. Through these fungal highways, plants can access nutrients and water from soil volumes hundreds of times larger than their roots could reach alone. Arbuscular mycorrhizal fungi form symbiotic relationships with over 80% of plant species, essentially creating a secondary root system that dramatically expands a plant's ability to thrive. The synergistic relationships don't stop there. Protozoa and beneficial nematodes act as the soil's recycling crew, consuming bacteria and fungi and releasing nutrients in forms that plants can easily absorb. This creates a continuous cycle of nutrient cycling that ensures plants have access to exactly what they need when they need it. The result is a self-sustaining system that can support plant growth far beyond what any single amendment or fertilizer could achieve. Perhaps the most fascinating aspect of soil microbiomes is the sophisticated communication system that exists between plants and microorganisms. Plants are far from passive recipients of microbial benefits. They actively participate in recruiting and managing their underground partners through a complex chemical language that scientists are only beginning to understand. This communication begins with root exudates, the organic compounds that plants release into the surrounding soil. These chemical messages include sugars, amino acids, organic acids, and specialized compounds called flavonoids. Think of these exudates as a plant's way of posting job listings in the soil, attracting specific microorganisms that can provide the services the plant needs most. When a plant requires nitrogen fixation, it releases specific flavonoids that act like a beacon, calling nitrogen-fixing bacteria to form partnerships. When facing drought stress, plants may release different compounds that attract microorganisms capable of improving water retention and stress tolerance. The microorganisms respond to these chemical signals with their own sophisticated messaging system. Beneficial bacteria produce plant growth-promoting hormones like auxins and cytokinins, which stimulate root development and overall plant growth. Some microbes release volatile organic compounds that can influence plant gene expression, essentially helping plants optimize their growth and defense strategies. The practical implications of this communication system are remarkable. Plants growing in microbiologically rich soil demonstrate dramatically improved nutrient uptake efficiency, often requiring 50% less fertilizer to achieve the same growth rates as plants in microbiologically depleted soil. They also show enhanced resistance to diseases, improved drought tolerance, and better overall vigor. The difference is so pronounced that experienced gardeners can often identify microbiologically healthy soil simply by observing the robust, deep green foliage and vigorous growth of the plants growing in it. Understanding the science behind soil microbiomes is exciting, but the real value lies in translating this knowledge into practical strategies that transform your garden. Creating and maintaining a thriving soil ecosystem doesn't require expensive equipment or complicated procedures, but it does require a shift in thinking from quick fixes to sustainable soil building. Compost tea represents one of the most effective ways to introduce beneficial microorganisms to your soil. Unlike simple composting, actively brewed compost tea creates optimal conditions for multiplying beneficial bacteria and fungi. To create your own microbial powerhouse, combine high-quality compost with non-chlorinated water and aerate the mixture for 24 to 48 hours. Mycorrhizal inoculants offer another powerful tool for enhancing soil microbiomes. These products contain spores of beneficial fungi that quickly establish partnerships with plant roots. When transplanting seedlings or direct seeding, applying mycorrhizal inoculants directly to the root zone can establish these crucial partnerships from the very beginning of a plant's life. The investment in quality inoculants pays dividends through improved nutrient uptake, enhanced drought tolerance, and increased overall plant vigor. However, building a healthy soil microbiome isn't just about what you add. It's equally important to avoid practices that harm existing microbial communities. Excessive tilling destroys the delicate fungal networks that take months or years to establish. Synthetic fertilizers, particularly those high in nitrogen, can disrupt the natural balance of soil organisms, often leading to the dominance of harmful bacteria over beneficial species. Chemical pesticides and herbicides can devastate entire microbial communities, creating soil that may look healthy but lacks the biological activity necessary for optimal plant growth. The benefits of maintaining a healthy soil microbiome extend far beyond just faster growth. Plants growing in microbiologically active soil demonstrate remarkable resilience to environmental stresses. During drought conditions, the improved soil structure created by fungal networks helps retain moisture, while mycorrhizal partnerships increase the plant's ability to access water from deeper soil layers. Disease resistance improves dramatically as beneficial microorganisms outcompete pathogens and produce natural antibiotics that protect plant roots. Even pest pressure decreases as healthy plants produce stronger natural defense compounds and attract beneficial insects that help control harmful species. As we wrap up this deep dive into the microscopic world beneath our feet, I want to challenge you to fundamentally change how you approach gardening. Instead of focusing solely on the plants you can see, start paying attention to the soil ecosystem that makes everything possible. This shift in perspective represents the future of sustainable gardening and the key to achieving the kind of spectacular results that leave neighbors wondering about your secret. Begin by becoming a soil observer. Take time to examine your soil's structure, smell, and biological activity. Healthy soil should have an earthy, pleasant aroma and be teeming with visible life like earthworms and beneficial insects. Start experimenting with the microbial strategies we've discussed today. Begin with compost tea applications and observe how your plants respond over the following weeks. Try incorporating mycorrhizal inoculants when transplanting and compare the growth rates and health of treated versus untreated plants. Document your results through photos and notes, creating your own case studies of microbial success. The ripple effects of healthy soil extend far beyond your garden boundaries. Microbiologically active soil sequesters more carbon, helping combat climate change. It reduces the need for synthetic inputs, protecting groundwater and surrounding ecosystems. It creates habitat for beneficial insects and other wildlife, contributing to biodiversity conservation. By focusing on soil health, you're not just growing better plants, you're participating in healing the planet one garden at a time. Remember, transforming your soil microbiome is a journey, not a destination. Each season offers new opportunities to observe, learn, and improve. The microscopic partnerships you foster today will continue paying dividends for years to come, creating a garden ecosystem that becomes more productive and resilient with each passing year. That's a wrap on today's exploration into the incredible world of soil microbiomes. If this deep dive into the underground ecosystem has sparked your curiosity and given you actionable strategies to transform your garden, make sure to hit that subscribe button and ring the notification bell so you never miss our latest gardening insights. Share this video with fellow gardeners who are ready to move beyond basic soil amendments and unlock the true potential hidden in their soil. Drop a comment below sharing your own soil microbiome experiments and results. I love hearing about your successes and learning from your experiences. Until next time, keep growing, keep learning, and remember that the best gardens are built from the ground up.